All right, guys, so nonlinear systems is really a very broad topic. It could mean, two circles are intersecting, or a parabola and a circle, or a hyperbola and an ellipse, and all these things you haven't heard about. All we're going to concentrate on today for nonlinear systems is a parabola and a line, okay? You could solve these graphically if you can isolate the y, but on the quiz it does say that you need to show your algebra. So what we're going to do for this first question is this first one. Does everybody see it has an x squared and an x and a y? We're going to substitute this y of 2 minus x back in up here. So it will say negative 2x squared minus 25x minus 3, but instead of y, we're going to write a 2 minus x, then a minus 50, and they've given it to us in equals 0 form, which is nice because I don't know that Delta Math does it exactly that same way, but eventually it had to equal 0 so that we could factor it. We're going to distribute this negative 3, and then we'll collect up all our like terms. So we have a negative 2x squared minus 25x minus 6 plus 3x minus 50 equals 0. Everybody okay? All I did was distribute. So what do I have if I collect my like terms? Anybody? Negative 2x squared. (22x) and a negative 56. Okay, first thing I can do is take out a negative 2 out of everything. That'll leave us an x squared plus 11x plus 28 equals 0, I think. Did I divide everything by negative 2 correctly, guys? Okay. Can negative 2 ever equal 0? No, so we could actually divide that out and not worry about it. This will factor x plus 7, x plus 4 to make a 28 and add up to an 11 in the middle. So then I get what two x values, guys? Negative 7 or x equals negative 4. Now, you're going to want to be real careful because think about, I should have started with this conversation, but if we're talking about a parabola and a line, how many times could those intersect? 2 at the most. What about at the least? Could they intersect once? Could a parabola hit a line hit a parabola exactly once? Yes. Could a line never cross a parabola? Yes. So we could have, something like this where they never intersect. We could have something like this where they hit once. We could have something like this where they have 2 intersection points, okay? What did we just find? Well, we found 2 different x values. So negative 7 is one x value, and negative 4 is another x value where these intersect. To find the corresponding y values, we can go back up to this equation. Remember this little guy, y equals 2 minus x? So if we go down here and we say y equals 2 minus negative 7, or y equals 2 minus negative 4, that'll give us the y value for those. Does that make sense? I think this is 9. And this would be positive 6. Did I do those right, guys? Okay. But you need to find an XY ordered pair as your answer, or say no solution if there isn't one. All right, we have 3 more of these. This is actually what the Delta Math looks like, is more like 3 and 4 here. So I'm going to go to these, okay? I'm going to skip example 2 because I don't think that's what the Delta Math looks like. This is what the Delta Math looks like. It gives you equation for a parabola, equation for a circle, or I'm sorry, a line. How can we solve that by substitution, guys? Yeah, just put this y equals the 2x plus 8, or it doesn't matter the other way around, but in for the y up here. So that gives me 2x plus 8 equals 2x squared plus 7x plus 10. Then if I have an x squared, I need to solve by factoring or quadratic formula or square rooting or something. So I need to get it equal to 0. If I subtract both of these over to the other side, I will have a 0 and a 2x squared plus 5x plus 2. Did anybody else get that? Okay. How do we make a 2x squared? We need a 2x and a 1x. And to get a 2 back here, we need a 1 and a 2 or a 2 and a 1. Anybody have a preference? It's going to have to be a 1 and a 2 so that this gives us 4x and this arch gives us 1x so that they add up to that middle 5x. So we just factor carefully. Then if I set each of those equal to 0, 2x plus 1 equals 0, I would get what, guys? -1, and then I'd have to divide by 2. Everybody okay if I skip some of those steps? And this one, if x plus 2 equals 0, I would get a -2. Now remember, those are both x values. They do not go together in an ordered pair because they are both x values. So how do we find the y value that goes with each of those? Well, we had one, we could plug it in either one of those. It looks easier to me to put it in the second one, yes. Y equals 2x plus 8. Y equals 2 times that x plus 8. So y equals 2 times that x plus 8. Okay, 2 times the -1/2. You could do this all on your calculator, but I'm thinking it's 6. Did anybody get a 6 there? No, why did that become a 7? Wow. Is it a 7? Half of 2 is 1. It's a -1 plus 8 makes a 7. Ooh, don't erase off power. Okay, sorry, I don't know what happened to me there for a minute. Over here, we'd have a -4 plus 8 is 4. Did anybody else get those? Okay, one more time. Could you solve that by plugging into your y equals on your calculator, this parabola and this line? And what would you be looking for if you graphed them on your calculator? Yeah, the intersection, the 2 points where they intersect, okay? You are going to have to show the algebra on your quiz, but does everybody know what I'm talking about, or do you need me to show you how you could graph it as a parabola and a line and find where they intersect? That's all we're finding is those intersection points, okay? I'm actually going to skip 4 as well and keep going here because I think you get the basic idea. Yes? Okay. We're going to talk about matrices today. The magic of matrices is going to become more obvious tomorrow. Today, I just want to talk about what they are and the basics, okay? So there are many, many applications of matrices. It talks here about cryptography, cable industries, encryption, which is basically the cryptography thing. In economics, matrices are used. Computer animations is all about matrices to provide scaling, flipping, translating, rotating. But we're going to talk today just about a very basic use of a matrix as a way to organize data, okay? So, is everybody paying attention here? You will have to know for the final and for the quiz on this and for today's homework, the dimensions of a matrix. A matrix is just like a little chunk of a spreadsheet, okay? It's going to be, this is a 2x3 matrix where you've just put some values in. It is the number of rows by the number of columns, okay? This cute little graphic talks about rows come first and then columns like RC Cola, but I don't know if you guys even know what RC Cola is. It's like a generic Pepsi or Coke. Anybody ever have RC Cola? Anyway, the rows by columns. Rows go across. This is a row, 2, 0, negative 5. This is a row, negative 1, 3, 6. Okay? A column is up and down, like the columns or pillars on the front of a house. Do you know what I'm talking about? They call those, okay, those are columns. So, again, how many rows are there? How many columns? So let's look. This is an application used. Is somewhere I have a slide that just says notes. Is this? You guys have a slide that says notes. Here it is. Okay. So notes on matrices for you. The order, okay, Delta Math calls it the order instead of the dimensions, are the number of rows by the number of columns. So a row runs this way. 1, 2, 3. That is a row. 4, 5, 6. Okay. So this rows go this way. Columns go up and down. So this has 2 rows by 3 columns. You can have a square matrix, so it could be a 2 by 2. That would be real easy, right, to tell, as you could get it backwards and wouldn't matter. What would this one be? What would the dimensions on that one be, guys? 4 by 1. Does everybody see that? There's 4 entries all in one column. Okay. We'll do some more examples as we go through some of the rest of this. I'll show you. We'll talk about the dimensions on each one just to give you practice, but I don't want to bog you down with 15 examples in your notes. We're going to talk today about adding and subtracting matrices. Okay. Addition and subtraction can only be performed if 2 matrices are of equal dimensions. Let's see. I am going to say I own the Chick-fil-A on East State in Perryville. And then I own the Chick-fil-A on 173, or I'll call it Alpine. How's that? So here's my buns. We have grilled chicken and fried chicken, and we have buns and whole wheat buns for the grilled chicken. Okay, so this is my inventory in one store, and this is my inventory of the same items. You don't need to write this example down if you don't want, but in another store. If those are the same size and everything's organized in the same way, could I find my total inventory by adding those entries together? Okay, that's a use of a matrix. Does that make sense? So I could add these together and say my total inventory is 1 plus 2, because this is also buns and wheat and grilled chicken and fried chicken. 1 plus the 2 over here would make the top left corner here, which is called the 1, 1 entry, but you don't need to know that. 1 plus 2 is 3. This one was a 2 plus 1 is 3. 4 plus 4 is 8. 7 plus 5 is 12. Anybody have a question where those came from? Okay. It's just like you put them right on top of each other and you added them together. Can you do that on the quiz or the final exam? Because that's a question. Okay. Not hard. Some of them might be negative, some of them might not be. So they can be added and subtracted if they are of equal dimension. Otherwise, it's not possible. And I have an example somewhere of a scalar multiplication here. Scalar multiplication, I'll put something in that notes section in just a second, but it simply means you can multiply every entry in there by something. They show here that you could multiply an X onto everything. Here's an example that used to be on the final. I think I took it off because we're not going to have a lot of time on this week, but for example, I had these candy prices came in. These were Snickers, Milky Way, and Reese's, okay? They came into my store and I'm gonna stock them. But I've decided to cut the price by 5%. What would I multiply by if I wanted that price to go down by 5%? Be careful. I could multiply by 0.05. But then I'd have to go back and subtract it off of each one, right? Does anybody remember how else we could do that? Yes, I could say I want to keep 95% of the price. Does that make sense to some of you? So I could multiply everything by 0.95, and that would come up with a new set of prices for those items, okay? Here's another one. What if I said I'm going to bump everybody's grade 12%? So these were the grades, and I said I'm going to bump you all up 12%. So I could multiply by 12 and add it on, but I could also say I'm going to give you all of this score plus another 12%. So what percent would that be? 112%. Does that 1.12 I could multiply by, and that would be your new score, okay? So multiplying by a scalar, let me find my little notes sheet again. Maybe, here it is. Scalar multiplication is simply multiplying a constant of some kind, or it could be a variable. I guess I should just say multiply every element, they're called, every item in there by something. I'll call it a quantity. How's that? You're multiplying every item in there. It could be by an X, it could be by a Y squared, whatever, but a scalar multiplies to everything. We're going to talk more about matrix multiplication and how you can multiply two matrices on another day. All right, so let's keep going with what you actually have in front of you. You have 4 questions that just say dimensions, guys? Okay, so help me out. What's this one? 2 rows this way by 3 columns up and down. What about number 7? 1 by 4. Number 8, 3 by 4. Yes, in delta math they use X, yep, or the multiplication symbol. I can do that on this one. This one would be 2 by 3, okay? Yep, you can write it that way. I just, for your notes, I'm really confused. Someone's gonna think that means 6, okay? It's not, but they will write it. In delta math, they give you a box, and you just have to put them in, okay? Easy peasy. All right. Can you combine these, add or subtract, or is it undefined? Again, how would we know that? Yeah, undefined would be if not the same dimensions or order, okay? I don't know why Delta Math calls it order. I've never heard that phrase, but they call it order instead of dimensions. I put both on the quiz, I think. So are these the same size? Yeah, so they are 1 by 2s, right? So we can add, and what's the size that's left would be a 1 by 2, and what would we get for the entries? The 6 would add to the 3 and would get a 9, and the -2 would add to the 1 and we get a -1. Yes? I can show you how to do this in your calculator, but it seems to me that that's a waste of putting things into the calculator, yes? You can just do that from the home screen. even if you had big gross numbers, you could just add them up and write them down, right? Rather than typing them all in and then finding a command to tell you to add them. Okay, what about this guy? Can't do, right? This would be a 2 by 1 trying to add to a 3 by 2, and it would be not defined or undefined, not the same size, whatever you want to write. Any questions on that? All right, number 12. This is a scalar problem. That 3 out there is multiplied, so you can do that. Scalar you can do to any size. So what will I get as my new entries when I multiply everything by 3? -6, 9, -3 and 3, and I didn't write my matrix long enough here. Any questions on that concept? All right, so this is combining all of that crazy business. This is not something that we would need to do necessarily in real life, but this could be the kind of thing that they use. For example, this would make something bigger or smaller by a factor of 3, and it might slide something across. So if it was an animation for something, that might be something they needed. But multiply everything by -3 in here, and we'd get 6, -12, and 15. Does that seem okay? And then because they're the same size, we can go ahead and combine them. Be real careful. Subtracting always makes me nervous. 6 minus -6 would become actually +6, so 12. Then -12 minus 5 would be -17, and 15 minus 4 would be 11. And again, the reason we had to do this first, okay, just so everybody knew where those came from, we took care of that scalar first. Order of operations, right? Multiply, then subtract. Everybody good? All right. Now, we're going to learn why these are useful and how to put them in our calculator to solve things for us. An augmented matrix is when you take a system of equations and you remove the variables. So this lined up system of equations will become 1, 5, then there was an equal sign, and a 17. And what would that second one become? -4 and -12. And you don't have to put the little dotted line down there. You can just put it all in one matrix as far as I'm concerned. You do have to know the size when you go to enter these in the calculator. This is a 2 by 3. Everybody good? Understand how that, okay. So what would number 15 look like if we just wrote the augmented matrix? Okay, now you do have to be careful, okay, that if it was not in an XY equal order, they have to be that way. Whoops, I don't know why that's dotted. Again, this was a 2 by 3. These have to be the X's, these have to be the Y's, and these have to be what they're equal to. Does that make sense, guys? It's got to have the same organization. It's like when I was talking about my Chick-fil-A thing. If one of my matrices had fried chicken with a bun, and another one in that same spot had the number of Coca-Colas I sold, it's not going to make any sense. So it's got to match up. All right, on to... So this one we need to rearrange, yes? -7x plus 4y equals 18. That first one looks okay. What would we need to do to the second one? Just add the 4x over there. So then we'd have a 4x plus y equals -7. I don't know if I said that first one wrong when I was reading it. So answer would just be -7, 4, 18, 4, 1, and -7. This seems kind of pointless right now. Tomorrow we're going to learn how to put these in our calculator, and it's going to solve the system for you. It's going to be magic. It's going to tell you exactly what x and y are, where those two lines intersect, okay? What do we want to do to this next guy? Say that again. Move the x over to the other side, yes. So it's going to be subtracted over to the other side. Is everybody okay? If you subtracted the y to this side, that would be okay too. It just has to somehow match up so that I'm going to make it negative 7x plus 1y equals 0. Is everybody okay with what I did? So what would this next one become? Yep, that's good. So then we'll have negative 7, 1, and 0, and 6, 1, and 13. Now, what if someone had 7, negative 1, and 0? Can you always multiply an equation through by a negative 1 and it's still equivalent? It means the same thing, okay? You would still get the same solution. Now, obviously, you know, being in the whole 7 whole wheat buns and having 7 are not the same thing, but it's an equivalent expression in terms of you will get the same solution when we solve this system. All right, this is the same. We're going to talk more about solving a system of 3 variables. If you did it last year in Algebra 2, possibly, it's miserable, okay? It is miserable to solve these by hand. We're just going to use them, do them on the calculator today. I'm going to do one by hand to show you tomorrow. Okay, but this has to be x, y, z, and then what they're equal to. So the first one we're good, right? It has a negative 5, a 1, a 6, and a 27. Everybody okay? What about that second one? Anybody know how we're going to put this little guy in there? Yeah, perfect. 3, there's no y's, negative 1z, and a negative 17. Everybody going to be okay with that? Once you get the hang of this, you're just going to love this stuff. It's going to be the easiest questions on the quiz or the final. And then this last one did have all of them, right? It had a negative 2, a negative 5, a negative 6, and a 3. All right, can you try 19 on your own? The first one needed a 0 where? Yep. Do you have more of those? Okay. How much time do we have left? Okay, I'm going to keep going. Does somebody want to pick one of these word problems? These are examples of things that you might have. Oh, there's only 3 of them? Oh, at the bottom you have a Delta Math 1. I might actually have that on here. Okay. All right, let's just run through. Yeah, whether we solve or not is not as important as setting him up. Okay, you had a Delta Math questions with some systems on the very first assignment, and some of you might have gone like, I don't remember how to do these word problems. So I'm just going to run through this with you. I read the whole question, but then I always go back and I ask, what is it actually looking for at the end? So Mark and Wilbur each improved their yards by planting daylilies and ornamental grass. They bought their supplies at the same store. Mark spent $172 on 3 daylilies and 14 bunches of ornamental grass. Wilbur spent $161 on 14 daylilies and 7 bunches of ornamental grass. What is the cost of 1 daylily and the cost of 1 bunch of ornamental grass? In Delta Math and on the quiz and on the final, it is going to ask you what your variables represent. You don't have to use X and Y, which is really nice in Delta Math. I'm just going to use X and Y. What are the 2 things it asks us to find, guys, specifically? Don't shorten it up for me. What does it say? What is cost of a daylily and the cost of a bunch of grass, right? Ornamental grass. Please be specific, okay? Because in Delta Math, it's a pull down menu and it's gonna say number of daylilies, number of bunches of whatever. It's gonna say cost. It might say the weight of a daylily. You know, you gotta be very specific what it is that you're actually finding. And then we just go back up and we write the two equations. Okay, this says 3 daylilies, 14 bunches of grass, and it costs $172. So somehow we have to change that 3 daylilies into dollars. Well, they each cost how much? X, right? So 3 times X would be the cost of daylilies. 14 of these Y's, whatever they are, the cost of a grass, 14 grasses totaled. So we add them together, $172. Does that equation make sense? So it's 3 times the cost of a daylily plus 14 times the cost of grass equals $172. Guess what? Wilbur did the same thing. What's his going to look like, guys? 14 daylilies plus 7 grass equals 161. Okay. One of them on Delta Math you actually have to solve, and eventually you're going to have to solve more. I'm going to show you how eventually to do these with matrices. This would be 3, 14, 172, 14, 7, 161 if you were doing it that way. We could also multiply this bottom one through by a -2 and the y's would drop out. Yes? Anybody remember doing that? So 3x plus 14y equals 172. We could multiply this by a -2 and it would become -28x minus 14y equals -322. When we added those together, the y's would drop out. We'd have -25x equals -150, I think. Someone I hope is checking this. And then you divide and get x is 6. Anybody checking my math? I think my math might be right because this came out 11. So we got $6 for a daylily and $11 for a bunch of grass. All right, we're going to learn to do that without all that algebra. How about the Delta Math one? You want me to set that one up real quick if I have it? The coin guy? Wasn't it a coin problem? Darn it, why do I not have it? I was sure I had it. Is it 23? Okay, can someone read it? Is it dimes and nickels, quarters? What is it? So I'm going to go x equals, we're missing the number, right? Number of dimes. Y equals number of quarters. Is that what you said, dimes and quarters? Okay. And the total number of coins, do they tell us that? What does it say? I'm sorry, total number of coins is 20. So x dimes, that's the number of dimes plus the number of quarters equals the total number. So this is numbers of coins we're talking about here. Then there's another sentence that has to do with their value, and this is not given in the question. What is the value of a dime? 10 cents, right? What is the value of a quarter? 25 cents per quarter. And what is the total value of money that they gave us? $3.85 or 95? 335? All right. We could do substitution. We could do elimination. Eventually, you'll be able to do matrices. Just solve that. How we doing? Be okay? All right, I don't think there are any word problems on today's, this one that says matrix intro and more. Okay. But you should have 2 delta maths done now on matrices. One was called review of systems. Everybody good?